Section 1.3, Graphs of Functions. The graph of a function f is the collection of ordered pairs x, f of x, or x, y, such that x is in the domain of f. Your x value is the directed distance from the x-axis, and f of x or y is the directed distance from the y-axis. Here we want to find the domain and range of a function. We're going to use the graph to the right to determine the domain of f, the range of f, and the function values f of 1 and f of 3. So first we'll start by clarifying the points on the graph that will help us figure out the domain and range. If we look at this point here, that coordinates of that point is -1, -5. If we look at this point right here, that point will be the point 2, 4. And if we look at this last point here, we're going to have an open circle at the point 4, 0. So when I want to figure out my domain, I'm going to look at my graph moving from left to right. The first x value that I come across is this one right here, of -1, that goes with the coordinate -1, -5. And if I keep moving across the graph, the last x value that I'm going to come to is this 0.40, which has an x value of 4. So therefore, I'm going to say that my domain runs from the point -1 with a bracket because that point's included, to 4 with a parenthesis because that point is not included because of the open circle on the graph. For my range, I'm going to look at my y values from bottom to top. So at the bottom here, the first point I come across is -5. And if I travel up the y-axis, the last point I get to is 4. So therefore, my domain is going to run from -5, which is included, to +4, which is also included because of those closed circle points on the graph. For part C, the function values f of 1 and f of 3. We're referring to x, f of x. So in the first case, they want us to find 1, f of 1. So this is asking for the coordinate of the graph where x is equal to 1. What is the corresponding y? So if I look at my graph and I look at the point x value of 1, I can see this point here, 1, 3, is on my graph. So therefore, f of 1 will be equal to 3. For the second one, where we want f of 3, we're looking at an x value of 3 on the graph. So I go to my graph and I locate 3, and I plot that corresponding point, which is also 3. So therefore, f of 3 is equal to 3. Here we're given a graph of f of x equals x minus 4. The domain of this graph, when we look at our x values from left to right, the first point on this graph is the point 4, 0. So our first x value is 4, and our last value is infinity. The graph is continuous to the right. For our range, if we look from bottom to top, our lowest y value is 0, and our highest y value is infinity. So we'll say from 0 to infinity. Here we're discussing the vertical line test. The graph is a function if a vertical line drawn through the graph only intersects the graph at one point. And note below that we determine if the inverse of an equation is a function, we use the horizontal line test. Here we have two examples. We want to determine if the following graphs are functions, and then if the inverse of each of these graphs is a function. So if we look at our first graph and we perform the vertical line test, we can see that this is not a function, as the vertical line passes through more than one point. And if I draw a horizontal line through the graph, it does pass the horizontal line test, so therefore we could say that the inverse of this graph is a function. If we look at our second example, and we perform the vertical line test, we can see that this is a function. And if we perform the horizontal line test, we can see that the inverse of this graph is not a function.